Welcome all. My name is Naveen Chauhan, and in this video lecture series, now we are on a unit number 3, and the topic name is Multicast Routing Protocol. So far we have discussed about the Unicast routing protocol like uh, link state routing protocol and distance vector routing protocol and some internal routing protocols. So in this video, we'll go through some multicasting routing protocols. So before moving on to the multicast routing protocol, we will recall the basic terminology like unicasting, multicasting, and broadcasting. And based on this, I will tell you what should be the exact difference between multiple unicasting and exact multicasting. Then we will move on to the routing protocols, some multicasting routing protocols. So unicasting is very simple. So in unicasting, one source station transmit the packet to the destination address, and throughout this, the communication, there is only the one dedicated packet which is moving from one point to another point, and whenever it reaches to any of the intermediate routers, so it will only forward through the single interfaces. So router forward the received packet through only one of its interfaces. However, then multicasting is different. The router may forward the received packet through several of interfaces. The several of interfaces means whenever the intermediate router detects that on a different of interfaces, there should be at least one of the system which belongs to specific group, then immediately it will replicate the packet. It creates the duplicate copy. Still, but the concept is similar to the unicasting. Only the single packet is transmitted from one point to another point, but if it detects on a different interfaces, at least one of the system is belongs to group G1 is lie, immediately it will generate the replica. However, the multicasting and multiple unicasting are the different, and we cannot utilize the multiple unicasting concept as to represent the multicasting. The reason is on a figure number A, multicasting. So the source is sending a single copy from S1 to the other belonging networks. Those having at least one system belongs to G1. Whenever it reaches to router and router decide that the both the having it's the interface is having at least one computer which belongs to G1, so it just generate a replica. However, in a multiple unicasting, total number of packets, it's mean the number of the computers of specific group, so that many number of packets are transmitted from source and moving towards the uh, individual destinations. So the first point, so if we utilize the multiple unicasting, so it may create longer delay. The reason is the source, your computer is not capable to transmit all the packet simultaneously. So it transmits the packet one by one into the network or into the communication. So it means, so suppose, so we can assume the delay that will faced by the your last packet or the last frame. So that's why it may create the longer delays, and particularly with a large group. So we can assume thousands number of the system with the groups that those belongs to a particular group. The shortest path tree in a unicasting routing protocol. So, and we all are familiar with this structure. So this is the structure of unicasting routing protocol, where the every router needs to maintain the shortest path. So I'm just focusing on this R1 table. So it maintains then all the networks belongs to this intra network, as well as the second column the next hop. If any network is directly connected to that particular router, so there will be a dash. However, rest of these, the R2 and R4, these are the next hope through which possibly we can reach to these networks, these respective networks like N2, N3, N4, and N6. Now based on this, we can maintain the some routing protocols like source shared tree and group shared tree. In the source shared tree approach, every router, those are the part of these multicasting phenomena, they have to maintain the similar routing table of shortest path tree like the unicasting. we have done with the unicasting. So in multicasting routing, each involved router needs to construct the shortest path tree for each group. So just focus on this R1 table, and we are just maintaining the routing table for R1 router. So now the destinations, or the first column, that will be all the groups, right? And for respective to the G1 group, why these three values dash R2 and R4 is showing, these are actually just find out the different networks where at least one of the system belongs to G1. So there is on the top G1, G1, G1 and G1. So first I'm just finding out G1. This is directly connected, so there will be the dash. Now for this G1, we can reach to this G1 through this R4. That's why the last R4. And for these two G1 on the top and the bottom, there is the first next hop is the R2, through which R2 we can reach to these G1 top and the bottom. That's why. So similarly, we can maintain the shortest path source based tree, short shared tree approach for all the routers. How will in the group shared tree approach? The reason is that in a source shared tree approach, it is not feasible to maintain the shortest path tree to each and every group. Suppose we have a thousands of and a millions of groups in a network community, then each and every router needs to maintain these entries. To overcome this, so there is a very specific router or the centralized router that is called the core router or Rondio routers. The responsibility of these router is very similar to the responsibility of the all the routers was in the source shared tree approach. Now the core router maintain the similar kind of core router table, right? Now every router has a responsibility whenever it receives a group a multicasting packet, it just handed over to the core router. Now this core router responsibility how to reach this multicast routing protocol to all the other networks, right? So it means, so let's suppose I am a one of the system, I want to transmit one packet to the all the G1 groups, right, to the G1 groups. So I will hand over to this to my the router. Let's suppose I'm just connected with the R2, so I will hand it over multicast routing to the R2. So it will create a one unicasting packet, and it's very simple. Just take an envelope of unicasting routing protocol and just put your multicast routing protocol inside this and hand it over to the core router. Now the core router will consult with the core routing table and then will decide how to reach, how to forward these packet to all the networks belong to the G1. So now based on this, we can just divide the multicast routing protocol. Now source-based tree, we have OSP, multicasting open source shortest path, and we have multicasting distance vector routing protocol, and in group share tree we have common base tree. Now source-based tree approach, MOSPF, multicast link state routing protocol, uses source-based tree approach. Flooding broadcast the packet but create loops in the system. So if we are aware about how to create the shortest path tree in unicasting, so it just broadcasts the packets and then decides the shortest packet, shortest source tree. To eliminate this the flooding, they have using the RPF, eliminates the loop in the flooding process. So it is routing protocol flooding. And then we have RPB create, that is for broadcasting, and based on this we can create a shortest path broadcast tree from the source to each destination, and it guarantees that each destination receives one and only one copy of the packet. I'm just telling how the reverse path forwarding and reverse path broadcasting, right? So in a reverse path forwarding, so based on this flooding, let's suppose we have created a one route, a one uh, shortest source path. We have created a shortest path, right? So now it will just uh, forward these forward the packet back to the source through the designed route, right? So So RPF eliminates the loop in the flooding process, but there is a one situation. So more than one network get the duplicate packet from the other networks. So to overcome this situation, there is a reverse path broadcasting. RPB create a shortest path broadcast tree from the source to each destination. So it guarantees that each destination receives one and only one copy of the packet. So what is the solution? The solution is very simple. However, in RPF we work on the graph. However, we on RPB we work on the tree. So it means any of the network will have exactly one parent. So it means whatever I'm getting from the parent, that will work on that. So in this example, you can see the net 1 and net 2. R1 is the parent of net 1, net 2. However, R2 is the only the parent of net 3. So whatever I'm getting from R1 will not forward it to the net 3. So I will only believes on the what I'm getting from the R2. So that will eliminate the duplicate copies of the same thing. So group share tree with Randios routers. So this is another the category of multicast routing protocol where we work on the group shared. It means there will be one core router, and this core router, so in the picture one, the core router is responsible for maintaining the shortest path tree to each and every other group, right? So you can see, so whenever have a packet of multicasting, I want to transmit it to specific groups, I will transmit it as a unicasting. However, the core router will transmit this packet as a multicasting packet. So from this picture, it is clearly depicted. So in CBT, the source sends the multicast packet encapsulated in a unicast packet to the core router. The core router encapsulates the packet and forward it to the all interested interfaces. So protocol independent multicasting and dense multicast environments such as LAN. These are some other variations. So protocol independent multicasting, that is dense again, uses the RPF, so it uses the reverse path forwarding and pruning and crafting strategies to handle multicasting. However, it is independent of underlying unicast pod. So pruning is, if I am not wants the packet from a specific group, so uh, um, I will inform to my parent. It's mean I will inform to my router, and then router will decide not to forward any more multicast packets. But let's suppose after that I will the interest is again created to receive some particular packet from a specific group. So I will just generate some drafting messages back, the message to my parent or to my router. So in a sparse multicasting environment such as the WAN, so PIM SM is used especially in the sparse multicast environment. And SM is similar to the CBT but uses the similar procedure. For more details about the multicast routing protocol, you can refer the frozen textbook, the textbook named Data Communication and Networking, chapter number 22, 5th edition, McGraw-Hill. Thank you.